Hello friends, I am Dr. Sunil Sinhmar and I welcome you all in this YouTube channel Manufacturing Made Easy. And today I am taking this class after a long time. Earlier I was teaching on the whiteboard, but today I am as a trial I am using these white papers for teaching. So let's see whether it will be helpful for you or not. And पहले की classes में I have covered the, as you know, I have started a series that is based on the previous questions of the GATE exam, and I am covering the questions related to the manufacturing engineering. And in earlier videos I have covered the topic related to the welding. Hopefully this was helpful for you. And now onwards I will start the machining questions related to the machining process, and specifically today I will discuss about the electric discharge machining. So होपफुली ये जो ये मैंने YouTube चैनल बनाया है स्पेशली आप लोगों को मैन्युफैक्चरिंग के बारे में टीच करने के लिए, तो ये आप लोगों के लिए काफ़ी मददगार होगा. और अगर आप लोगों ने अभी तक इस चैनल को सब्सक्राइब नहीं किया है देन प्लीज़ सब्सक्राइब दिस चैनल and the videos, please watch all videos, and if these are helpful then you can like those videos. So today I am starting with electric discharge machining. And first of all, electric discharge machining, this is also in short form, this is called EDM, electric discharge machining, that is EDM. And one more thing is that regarding this YouTube channel or my videos, that I usually not just dictate the questions and tell you that this is the answer of this question. I always used to elaborate each and every term which is coming in the question solution. जो भी टर्म, जो भी कोई प्रोसेस, ऑपरेशन, कुछ भी अगर क्वेश्चन में आ रहा है तो मैं कम्प्लीटली उसको हर एक क्वेश्चन में एक्सप्लेन करता हूँ. जैसे आपने पहले मेरी वीडियोज़ अगर देखा तो आपको पता होगा. तो ये जस्ट ऐसे नहीं है कि क्वेश्चन बोला और उसका जो आंसर है वो टिक किया, नेक्स्ट क्वेश्चन ये वो, ऐसे नहीं है. टाइम ज़्यादा लगता है, क्वेश्चन कम कवर हो पाते हैं, बट मैं आपको थोरोली एक्सप्लेन करता हूँ जो भी टर्म्स उसमें आती है. ओके, सो लेट्स स्टार्ट विद इलेक्ट्रिक डिस्चार्ज मशीनिंग. तो सबसे पहले मशीनिंग क्या है? मशीनिंग, एज वी नो, द मशीनिंग इज ए मटीरियल रिमूवल प्रोसेस. दिस इज यूज टू मैन्युफैक्चरिंग समथिंग और टू मेंटेन और द साइज एंड शेप ऑफ द एनी ऑब्जेक्ट और मटीरियल. तो मशीनिंग में भी जनरली ब्रॉडली टू कैटेगरीज है. मशीनिंग की ब्रॉडली टू कैटेगरीज है. वन इज़ कन्वेंशनल मशीनिंग, कन्वेंशनल जिसको हम ट्रेडिशनल मशीनिंग भी बोलते हैं. सेकंड वन इज़ द नॉन कन्वेंशनल मशीनिंग. नॉन कन्वेंशनल मशीनिंग, the example of the conventional, first of all, what is the meaning of the conventional? Conventional is the machining process in which the tool and the workpiece are in contact. And now here two terms are coming, tool and workpiece. What is tool? Tool is that part which is used to remove the material from the workpiece, that is called tool. And workpiece is the second part from which we want to remove the material. Okay, so there are tool and workpiece in the machining. So conventional machining is that type of machining process in which there is direct contact or mechanical contact between the tool and workpiece. In conventional, there is direct contact between the tool and workpiece. For example, like shaping, and on lathe we can say turning, etc. Okay, and in non-conventional machining process, the process in which tool and workpiece are not in direct contact, they are not touching each other. So these are non-conventional machining processes, and example of non-conventional machining process is the like electric discharge machining, electrochemical machining, ultrasonic machining, etc. Okay, so conventional and non-conventional machining are clear, and as I have discussed, this electric discharge machining EDM comes under the non-conventional machining processes. So first of all, I will draw a schematic diagram of the electric discharge machining. Okay, like this is tool, this is a tool. So this one is tool, this one is tool, and this upper system is we can say broadly servo control. This is used to control the or feed the tool toward the workpiece. And second one is the there is a kind of container, and this is filled with a fluid that is called dielectric fluid. Dielectric fluid. So this is very important. Dielectric fluid is used in the electric discharge machining. This is very important thing. And here is our workpiece or metal piece. This is workpiece on which we have to perform the machining process. This is the workpiece and this is the tool. Upper one is the tool. So dielectric fluid is used, tool is used, and workpiece is there, and we have to supply the electric current. So this tool is connected with the negative potential and workpiece is connected with the positive potential. So this tool is called cathode, and this workpiece is called anode. So here the tool is cathode, that is connected to the negative terminal, and workpiece is connected to the positive terminal, that is anode. Now I will explain the working and why we kept tool as negative and workpiece as anode. I will explain all these things. Now before that, some of you may be thinking that why the fluid used is the dielectric type, not a simple fluid that is kind of electrolyte. So why dielectric fluid is used? First of all, what is dielectric? Dielectric means the fluid which is electrically non-conductive, and it is have very high resistance to the electrical breakdown. It is a non-conductive fluid, and sometimes at a particular condition it may behave as a conductive also, but that is different things. First we can define this dielectric fluid as the fluid which is electrically non-conductive fluid. So what are the example of this dielectric fluid? Like the fluids which are hydrocarbon fluid. or mineral oil. So example are like petroleum, kerosene is widely used, kerosene oil and paraffin oil, etc. Silicon oil also used. Now why we are using dielectric fluid? Because I have to draw some schematic, like this is tool and this is workpiece. There is dielectric fluid in between. So first, as we have given the negative potential to this negative terminal to tool and positive to the workpiece, as we start the supply of the electric current, then this cathode, there is a potential difference between tool and workpiece, and these due to this potential difference there is a electrostatic field electrostatic field is established. That is very strong electrostatic field is established between these tool and workpiece. Electrostatic field is established. So now, as we know, the if this tool reached to a up to a energy level, like energy level up to its work function, at that energy level it will start to release the electron from its surface. Tool will start to release the electron from its surface, and this is called cold emission by the electrode. So these electron start moving from this electrode surface or tool surface, and then there is dielectric fluid. It will collide with the dielectric fluid, and there is dielectric fluid molecules, and these electrons will break the dielectric molecule into the positive ions and electrons. नाउ देयर आर मोर इलेक्ट्रॉन. एक हिसाब से ये इलेक्ट्रॉन टूल से निकला और इधर डाइलेक्ट्रिक फ्लूइड का इलेक्ट्रॉन हो गया, तो इनका एक गैंग टाइप बन गया, ज़्यादा हो गए. और फिर ये मूव टुवर्ड पॉजिटिव टर्मिनल, दैट इज टुवर्ड वर्कपीस मूव कर रहे हैं. फिर देन दीज ऑल इलेक्ट्रॉन्स विल स्ट्राइक और कोलाइड टू द other molecules which are coming into the way towards this workpiece, and more electron will release. So these electron are moving through this. So there is a kind of, this way is ionized, this is strongly ionized, this way narrow zone, this narrow zone between this tool and workpiece is ionized. This is tool and this is workpiece. So this way is ionized, negative electron are moving toward this is ionized, positive is toward this. So this is ionized here, and this is form a kind of column, ionic column. So conductivity through this column will increased, and it will looks like a spark. So a spark is created because there is a kind of plasma or spark is created. So this spark will strike to the workpiece and create huge amount of heat will be released there. Due to this heat released and high temperature will reached, वर्कपीस पे बहुत ही हाई टेम्परेचर हो जाएगा. अप्रोक्सीमेटली आप ये मान लो 10,000 to 20,000 डिग्री सेंटीग्रेड तक का टेम्परेचर राइज हो जाता है. दिस विल cause the melting and evaporation. This is very important term, that is melting and evaporation of the workpiece, that will cause the machining of this workpiece. So hence in electric discharge machining, the machining take place due to this electron स्ट्राइक। एंड सो ये अपना EDM हो गया। अब ये एज वी आर यूजिंग हियर डाइलेक्ट्रिक फ्लूइड, ये डाइलेक्ट्रिक फ्लूइड इज नॉट स्टेशनरी, दिस इज वी आर कॉन्स्टेंटली रोटेटिंग और सर्कुलेटिंग और फोर्स्ड सर्कुलेशन, वी कैन से दिस, we are forcefully circulating this fluid, so it helps to take the scrap or material which is evaporated with itself, and also it also helps to improve the material removal rate and also improve the surface finish of the machined surface। तो ये हो गया डाइलेक्ट्रिक फ्लूइड के बारे में पूरा का पूरा, और इसका क्या काम है, हमारे डाइलेक्ट्रिक फ्लूइड का कैसे ये हेल्प करता है EDM के अंदर, ये मैंने पूरा आपको एक्सप्लेन कर दिया है। अब मैं इससे रिलेटेड जो भी क्वेश्चन होंगे वो क्वेश्चन लूँगा और वो आपसे डिस्कस करूँगा। होपफुली ये आपको समझ में आ रहा होगा। और एक मैं फिर से आपको बोलना चाहता हूँ कि अगर आप लोगों ने इस चैनल को सब्सक्राइब नहीं किया तो प्लीज़ सब्सक्राइब दिस चैनल एंड लाइक दिस वीडियो। अगर आपको हेल्पफुल लगे तो लाइक कर देना, अदरवाइज़ तो कोई ज़रूरत नहीं। तो ये पूरा EDM के बारे में हो गया, इलेक्ट्रिक डिस्चार्ज मशीनिंग के बारे में। एक और बात यहाँ पे नोट करने वाली है कि हमने जो टूल यूज़ किया है, हमने जो यहाँ पे टूल यूज़ किया है, ये टूल कौन से मटेरियल का होगा, तो ये कंडक्टिव मटेरियल का होता है। जो भी कंडक्टिव मटेरियल हम यूज़ लाइक मोस्टली कॉपर और कॉपर अलॉय का होता है या कॉपर टंगस्टन अलॉय का होता है, तो ये एक इलेक्ट्रिकली कंडक्टिव मटेरियल का टूल हम यूज़ करते हैं यहाँ पे। ये भी इम्पोर्टेंट है टूल से रिलेटेड। नाउ दिस इज़ द क्वेश्चन नंबर 1। ये 2003 में आया हुआ क्वेश्चन है। तो इज द टूल एंड वर्क आर नॉट इन कॉन्टैक्ट इन EDM प्रोसेस, टूल और वर्क कॉन्टैक्ट में नहीं होते बिकॉज दिस इज ए काइंड ऑफ नॉन कन्वेंशनल मशीनिंग प्रोसेस। सो विच वन इज करेक्ट फ्रॉम दीज ऑप्शंस? नो रिलेटिव मोशन occurs between them, no wear of tool occurs, no power is consumed during metal cutting, no force between tool and work occurs. Let's see these. First one is no relative motion occurs between them. There is a relative motion because tool is going downward as it is creating or machining the surface, or there is a crater is formed in the workpiece. The tool with the help of servo control system is going downward. So there is a relative motion occurs between the tool and workpiece. No wear of tool occurs. The wear of tool occurs there. It is not true that wear of tool not occur because mostly the material of the tool is a kind of conductive material. So high heat is also generating on this tool. So wear is also occurring here on the tool, and so to reduce this tool wear we generally use tungsten, copper tungsten kind of tool, so that wear will be less. No power is consumed during metal cutting. We are using power here, electricity, so power is consuming during the metal cutting. Fourth one is no force between tool and work occurs. Yeah, this is true because this is kind of non-conventional machining and no direct contact, so there is no force between tool and work occurs directly. Mechanical force is not there, so the option D is true. And I have earlier explained all these things in the on this previous page. So next question is, second question is the mechanism of material removal in electric discharge machining process is. We have to tell about the mechanism of the material removal. So first one is melting and evaporation, second one melting and corrosion, third is erosion and cavitation, fourth is cavitation and evaporation. And I have explained this, that the mechanism used is the melting and evaporation, because the melting due to the high temperature between at the workpiece is take place. So melting and evaporation is the mechanism of the material removal. So option A is the correct answer. Next, third one is the typical machining operations are to be performed on hard to machine materials by using the processes listed below. Choose the best set of operation process combination. That is, some material which are hard to be machined and some processes are given here. We have to choose the proper combination of between these. Operation are deburring, that is internal surface, die sinking, fine hole drilling in thin sheets, and tool sharpening. Processes are plasma arc machining. Second one is AFM. AFM is the abrasive flow machining. Then EDM. EDM is electric discharge machining. Then USM. USM is the ultrasonic machining. Then LBM, laser beam machining. Then ECG, electrochemical grinding. ECG is the electrochemical grinding. So first of all, I will discuss or I will explain all these things, terms like operation, what is deburring, die sinking, and the processes like plasma arc machining, AFM, EDM, all these things. First of all, operation. What is the deburring? Deburring is the deburring is you know that when we perform some machining operation like some cutting or any kind of coining or any kind of machining operation, there will always be some kind of waste particle, waste material that is remains onto this machined surface. Those waste material is called the burrs. Burr. Burr. So deburring is the secondary machining process that is used after the first machining process. That is secondary machining process which is used to the remaining particle or burr from the machined surface. So this is the deburring. And next is the die sinking. Die sinking. Die sinking is the process of machining process to machine a cavity in the steel block. Means any kind of material or block, specifically in the steel block, when we are machining a cavity, that is called die sinking. So die sinking is related to the producing a cavity in the steel blocks. So how this, what we do with these cavities? These are generally used for the molding the plastics material, hot and cold forging, and like hot and cold forging, die casting, coining, etc. ये सब करने के लिए हमें इस कैविटी की जरूरत पड़ती है, इसलिए डाई सिंकिंग इज यूज्ड टू प्रोड्यूस द कैविटी. ओके, एंड नेक्स्ट इज द फाइन होल ड्रिलिंग इन थिन शीट्स. दिस इज सिंपल. फाइन होल ड्रिलिंग इन थिन शीट्स में फाइन होल किस लिए करते हैं वो देख. एंड टूल शार्पनिंग, जैसे एनी काइंड ऑफ टूल शार्पनिंग करने के लिए हम क्या यूज़ करते हैं, तो ये हमें बताना है. सो नाउ आई विल डिस्कस अबाउट द प्रोसेसेस, वेरियस प्रोसेसेस. First one is the plasma arc machining. Plasma arc machining. So plasma, what is first you should know what is the plasma. As we heat a solid, this will become liquid. As we heat liquid, this will become gas. As we heat the gas, suppose further for 2000 degrees centigrade, we heat the gas, its molecule will dissociate into the atoms. Okay, and if we further heat these atoms or gas, suppose up to 3000 degrees centigrade further, so it will the electrons of these atoms will be displaced. Electrons in these atoms will be displaced. So these will create a kind of spark or plasma. So this is called plasma. This is also called a fourth state of the matter. Plasma is also called the fourth state of the matter. So this is plasma. And plasma arc machining. What is plasma arc machining? A high velocity gas. And for plasma generally we use gas like argon and hydrogen. So argon and hydrogen gas are used for the plasma. So high velocity gas, when this high velocity gas is used for at a high temperature is like 25,000 degree centigrade to the 28,000 degree centigrade. At this temperature, when this plasma or hot high velocity this plasma or air or gas will strike to the material, then it will cause the melting of that material. So this is called plasma arc machining, as we use in plasma arc welding. But the velocity somewhat is, in case of plasma arc welding, is less of the hot gases, this plasma, as compared to the plasma arc machining. Means in plasma arc machining the velocity of the plasma is more as compared to that welding. Next is abrasive flow machining. Now I will discuss about the abrasive flow machining. AFM, abrasive flow machining. In this abrasive with some fluid carrier is used. Abrasive like Al2O3 or boron carbide are used with some carrier gas, and with high velocity these strike to the surface of the material, and it will cause erosion on the material. So this is called abrasive flow machining, and these are generally used for the internal parts. So this is also called abrasive flow machining, is also called the abrasive flow deburring. These are generally used for the internal part finishing of the internal part or internal surface of the any part or job. Next is the EDM, I have explained earlier. Then ultrasonic machining. This I have taken uploaded 2 or 3 lecture on this ultrasonic machining with full explanation, so you can watch those lectures or videos. Then laser beam machining. This is simple. Laser is used to machine the object or workpiece. Then ECG. What is this ECG? Electrochemical grinding. This is the combination of the grinding process and electrochemical process. Now I will draw the schematic of the electrochemical grinding. This one is the wheel, electrochemical grinding wheel. This is wheel, and this is the workpiece, and there is a nozzle through which the electrolyte is flowing in between the wheel and workpiece. Wheel is connected to the negative terminal and workpiece is connected to the positive terminal, and this wheel have the metal bonded structure, also comprising the abrasive, non-conductive abrasive in between them. Okay, so the workpiece must be conductive material, so we can perform this electrochemical grinding. And it along with grinding, it also uses the electrochemical machining process in this. So this was all about the electrochemical grinding. Now we will match the correct operation with the process. So deburring is the process to remove the burrs, and as I have explained, we use the abrasive flow machining for this. Second one, die sinking. Die sinking is to produce a cavity, and it is performed with the help of electric discharge machining, EDM. Third one is the fine hole drilling in thin sheets. For thin sheets machining, we generally use the laser beam machining. Okay. And next is the tool sharpening. Tool sharpening, for sharpening of the tool, generally grinding is used, so electrochemical grinding. All these things I have explained clearly. So now we will see the next question. Now, next question is, a zigzag cavity in a block of high strength alloy is to be finished machined. This can be carried out by using. So this is a block, and we have to produce a zigzag cavity in this, as is shown in this diagram. We have to produce a cavity in this block, and this is a high strength alloy material. So only single thing is that for the cavities which are very complex, for complex cavities, electrochemical machining is used. इलेक्ट्रोकेमिकल मशीनिंग को यूज़ करते हैं हम कॉम्प्लेक्स कैविटीज़ के लिए. सो द करेक्ट आंसर इज द ECM, बी ऑप्शन. ओके. नेक्स्ट इज द arrange the processes in the increasing order of their maximum material removal rate. As material removal rate आपको पता ही है कि the material removed per unit time, mostly it is taken as in term of meter cube per second or meter cube per minute, and in some cases like ultrasonic machining, linear, we consider the linear material removal rate like meter per second or meter per minute. Okay. So this is the about material removal rate, MRR. These are the processes: electrochemical machining, USM ultrasonic machining, EBM is electron beam machining, LBM is the laser beam machining, and EDM is the electric discharge machining. So we have to arrange these machining process according to increasing order. First less MRR, then increasing. Okay. So now I want to explain some of the things like electrochemical machining, ECM, has high MRR, high material removal rate. This is generally between 200 to 300 meter cube per second. Okay. This is electrochemical machining has very high material removal rate. Next is the EDM. EDM is less than this electrochemical machining, and it is in between 10 to 20 mm cube per second. Okay. Then ultrasonic machining, it is generally considered as a linear material removal rate. And then EBM, electron beam machining, this has, if we talk in mm cube per second, then it is generally 0.16 mm cube per second. Okay. Or in term of mm cube per minute, it is 10 mm cube per minute. Or for LBM, laser beam machining shows exhibits very low machining rate, that is between 0.001 to 0.002 mm cube per second. And ultrasonic machining gives material removal rate in the range of 0.025 to 25 mm per minute. This is given in mm per minute because if we convert this in into mm cube per second, this will give the value will be very less. Okay, so these are the value of the material removal rate. So if we see, the highest is the ECM, okay, and lowest is the LBM. So the right option is the option D. First, very less is the LBM, then EBM, then ultrasonic machining, then EDM, then ECM. Okay, so option D is the correct answer. Now we will see the next question. Question number 6. In EDM, if the thermal conductivity of tools is high and the specific heat of workpiece is low, then the tool wear rate and material removal rate are expected to be respectively. ये क्या बोल रहा है कि अगर EDM में टूल की थर्मल कंडक्टिविटी हाई कर दी जाए, बहुत ज़्यादा हाई हो, एंड स्पेसिफिक हीट वर्कपीस की specific heat of workpiece is very low, then how it will affect the tool wear rate and material removal rate. So first, thermal conductivity of tool. As I told you, we take the tool which have very high thermal conductivity like copper and copper alloys. So thermal conductivity, high thermal conductivity is helpful. Okay, so the tool wear rate is less as the thermal conductivity अगर हाई होगी, हाई थर्मल कंडक्टिविटी अगर हम यूज़ करेंगे, तो जो हाई थर्मल कंडक्टिविटी यूज़ करेंगे तो टूल वियर रेट लेस होगा. ठीक है, तो ये इन्वर्सली प्रोपोर्शनल हो गया टूल वियर के. जितनी ज़्यादा थर्मल कनेक्टिविटी होगी उतना टूल वियर लेस होगा. सो हाई थर्मल कनेक्टिविटी इज डिजायर्ड सो दैट टूल वियर विल बी लेस. देन स्पेसिफिक हीट ऑफ वर्क पीस. अब स्पेसिफिक हीट क्या होता है? स्पेसिफिक हीट रिक्वायर्ड टू रेज द टेम्परेचर ऑफ मटेरियल बाय 1 डिग्री सेंटीग्रेड और 1 केल्विन. सो ये टेम्परेचर रेज करने, अब वर्कपीस का हमें टेम्परेचर रेज करना है क्योंकि मेल्ट करना है वर्कपीस को. वर्कपीस में हमें मशीनिंग करने के लिए उसमें मेल्ट करेंगे हम, तो उसका टेम्परेचर रेज करना है. तो हमारे लिए क्या ठीक रहेगा? मतलब कम हीट दे के अगर वो टेम्परेचर रेज हो जाए, मेल्ट हो जाए तो अच्छा है ना. मीन स्पेसिफिक हीट अगर हम कम देंगे, लो रखेंगे स्पेसिफिक हीट, तो मटेरियल रिमूवल रेट उसका अगर ज़्यादा मिले हमें तो वो अच्छा है ना. तो सो स्पेसिफिक ऑफ वर्क पीस इज लो, हीट रिक्वायर्ड टू रेज द टेम्परेचर ऑफ द मटेरियल इज लो, मटेरियल रिमूवल रेट जो हाई हो जाएगा अपना. तो ये क्या हो जाएगा? स्पेसिफिक हीट है, अगर लो होगी तो मटेरियल रिमूवल रेट विल बी हाई. मटेरियल रिमूवल रेट विल बी हाई क्योंकि हीट जो रिक्वायर्ड है वो कम होगी फिर. तो स्पेसिफिक हीट अगर लो है तो इसका मतलब हीट रिक्वायर्ड कम होगी तो मटेरियल रिमूवल रेट विल बी हाई हो जाएगा. तो ये हमारा था, मतलब जो टूल वियर जो है वो कम होगा, लो, एंड मटेरियल रिमूवल रेट विल बी हाई. तो ऑप्शन डी इज करेक्ट. ओके, सो आपको ये उम्मीद है कि अच्छे से समझ में आया होगा. दिस इज़ हेल्पफुल फॉर यू. एंड अगर आप लोगों को ये अच्छा लगा हो तो प्लीज़ लाइक दिस वीडियो. और अभी EDM का मैंने ये कवर किया है 10 ईयर में से. तो अब इसके बाद में मशीनिंग का ही कोई इसी सीरीज़ में, क्योंकि हमने सीरीज़ स्टार्ट कर रखी है गेट क्वेश्चंस के लिए, तो इसी सीरीज़ में मैं आगे नेक्स्ट अभी देखता हूँ कुछ अलग मशीनिंग प्रोसेस या कुछ मशीनिंग के अलग प्रोसेस के रिलेटेड क्वेश्चन लेकर आऊँगा. तो देखते रहिए और सब्सक्राइब करिए इस चैनल को. थैंक यू फॉर वॉचिंग.